All right, so for piecewise piecewise defined functions, I guess is what they call them sometimes. Your textbook does. All right, so what we have is we can have a y or an f of x. It doesn't matter. We'll have brackets, and then we have these subdomains that tell us that if you are located within this region, then this is your function. Now, in this case, you'll notice that all of our functions here are just constants, so they are going to be steps. All right. In this problem here, our functions will be lines. Okay. We even practiced harder ones where we could have each one step be an absolute value, and then the next step be a quadratic. So there's all kinds of varying levels of difficulty. Now in this one here, we're going to focus on each subdomain carefully one by one, and it looks like I have 4 pieces here. So I'm going to draw my graph. All right, these are going to be sloppy tonight. My graph paper is at school. I'm going to go all the way to -4. 1, 2, 3, 4. All right, and so from here to here, we drew lines. Okay, that we will erase. They are not part of the function at all, but we'll just use them for clarity. And it looks like I'm supposed to go down to -3. So -3 is a straight line that goes in between those values. Now it looks like I have a bar here, but I do not here. So this means on the border I will go right up to them, okay? But when I get to this -2 border, I will actually put an open circle and just leave it. All right. Now I'm assuming I'm going to go from -2 someplace else. Yes, I'm going to go from -2 to 0. But what's happened is that I've now gone up to -1. So now I go to -1. It looks like it's a bar, so I will fill that in, move over, but I do not equal -1 at 0. I just go up to it. The next one says I'm going to go to 2, from 0 to 2, and that guy's going to move up to 1. So +1, and I will fill it in here, move over to 2, fill that in. Okay? All right, then the next one, 3. So it looks like this is a kind of an arithmetic sequence in a way, in that every time in fact, it is an arithmetic sequence that happens to also be a function. So I'm going to go up 3, here, fill that in, and I'm going to move over to 4. All right, and I will not equal it at 4. All right, and that's my result. So this is 18 right there. That's the beautiful graph of 18. Now for 19. 19, it looks like we have some lines, and it looks like I have 3 of them. So I will, number 19 here, break this up. Looks like I go from 1, 2, 3, and then we go to 1, and then 1, and so forth. So we'll just do that. Okay, so I'm going to draw in these tick marks as I need to. Let me do that. I'm going to graph the first line, but the first line is everything that is less than -3. So this means I'm going to make it a little larger because my border is right there. My second border is there. So I have 1, 2, 3 pieces, and I'm going to draw 2x plus 5. So I go to 1, 2, 3, 4, 5, and that has a +2 slope. So if you remember, that's going to be 2 over 1, but since I have no room over here, I'm actually going to move to the left. And the left would mean that I would have to go down 2. So down 1, 2, 3, 4, 5. That's kind of a big space there. 1, 2 over 1. 1, 2, go over 1. 1, 2 over 1. Now remember, that's kind of, it should form a straight line. Now this guy is not going to exist until, bam, he gets to right here. It should be right there. Alright, so that's the piece that is less than -3. Yeah, the slope is terrible. I'm drawing looking at my screen here, so it should be like this. Okay. Alright. Now the next one is go to -2. I really wish I had graph paper. I really do. This one says I start at -2 and then the slope is -1, so I will go down 1 over 1. Okay, so it looks like at +1 I will not do that, but when I go the other direction, he will go here, and I will fill that in because we do have a bar when it equals -3. Now we have, for the last piece, is x minus 3, 1, 2, 3. Okay, and then the slope is up 1 over 1, up 1 over 1. But notice that I'm just putting the dots because I want everything that is past here to go in that direction. Okay, so this is our piecewise function, and I would erase the dotted lines here for number 19. Okay, all right, so for 20. All right, so I'm going to see that there are 3 pieces, and I'm going to put f of x instead of y. And I see that there are 3 pieces, and I might as well just take care of the subdomain first. It looks like the subdomain here is from everything where x is less than -3. I do not include them because I'm looking at this piece first. Then I will look at this piece. Then I will look at that piece. All right, the next piece will involve x being in the middle of 2 values. This is -3, and that's +2. So -3, include him. +2, include them. Now the reason why I'm including them is because I have filled in holes there. All right, and then the last subdomain would be, looks like I'm going to be in between 2 values too. I'm going to be in between 2 here. All right, so 2. Then x is going to go all the way to 5. All right, but we will include him because his location is actually filled in. It's solid. Okay, now that's that. Obi, what's up? Obi, go lay down, man. Stop barking at the cats. It's so aggressive. All right. So first of all, this one's the easiest one. That's 3, right? There's no slope, so that's just a 3. This guy looks like I have a slope of up 1 over 5. Okay, so up 1 over 5. Move that guy up a little bit. Up 1 over 5. And looks like it hits the y-axis at about, it's a little over a half. So I would probably estimate that at like 1.6 or 7. Okay. All right. And then this one actually kind of goes below the graph. So I'm going to have to kind of estimate how far below. The slope here is down 3 over 2, down 3 over 2. Okay. Obi, chill out. Obi, leave the cats alone. Okay. Down 3 over 2. Down 1, 2, 3 over 2. Okay, so looks like this guy will hit the x-axis at like -7 or like in a half, right? You don't have to worry about this on the test, but that's looks like it's going to hit at about -5, 6, 7, 8. Actually, -8. Okay, -8. So we're gonna approximate it at -8. So that slope is down 3 over 2 x minus 8. Okay, and that's it. That is the piecewise function. Okay, so now 21 says that every transformation of an absolute value can be written as a piecewise function. Explain. Yes. What is an absolute value other than a piecewise function written as one function, right? So this guy here would be like a -x, and this guy is the y equals +x. So what you do to create an absolute value function is you have this guy have a negative slope to bring it here, and as soon as you get to this vertex, then you will have a positive slope to go in that direction. All right, so it is 2 pieces, and so to answer that well, can every transformation of the absolute value function also be written as a piecewise function? Yes. It would be a piecewise function with two parts, one in which the slope is negative and one in which the slope is positive. All right, so that's number 21. And then 22, I'm not going to put something as hard as 22 on the test. It's pretty difficult. Basically, a coach is trying to decide how many new uniforms to purchase for a softball team. If the coach orders more than 10 uniforms, the cost for the extra uniforms is 0.75 times the normal cost per uniform of $120. So that means that 0.75 means that you're taking off 25%. So you get 25% off for every uniform after you buy 10. So we're going to write a piecewise function with this that gives the cost C in terms of dollars, in dollars in terms of the number of uniforms and the coach purchases. Then we will determine how much the coach will pay for 18 uniforms. Okay? All right, so let's wrap this one up. For 22, we have a piecewise function. Now, it said that he actually will pay $120 for every uniform that is less than 10. Okay, so if you buy a quantity less than 10, and that includes 10, by the way, but after that, things change. And this is where it gets complicated, because when you buy 11 jerseys, you don't want to forget about the previous 10. Okay? We know that the 11th jersey is going to be 25% off. We know that. But how do we write the function to reflect that transformation? Okay? So what we do is we figure out, first of all, I want to carry all of those 10 jerseys with me, because if I'm going to buy 11, that means I've already bought 10. 10 is part of the package. And those 10, if I were to multiply by 120, I'm going to have $1,200. $1,200. That's for the first 10. Okay? Now, that's the 10 aside. Now I want every number that is more than 10. 11, 12, 13, etc. So I'm going to have to add any number. Now I put x. This, to be very specific, should be n. And in fact, because we called that c, we should call this c. So let's call this c of x. Okay, c of x. And oh, no, not x. I just said n. Okay, so we're going to call that n. I'm so used to using x that I switched over. Now, I want every n that is more than 10. So I will get rid of the previous 10 that I already paid for. I already paid for it, so they're there. Okay? But on the 11th jersey, if I plug in 11, 11 minus 1, 10 is 1. So 1 times this. What is this? I need to take 75% of 120, because remember, I'm dropping it 25%. Okay? So I go on my calculator, and I go ahead and 120 times 0.75. That actually gives me 90. So that means I'm paying $90 for every jersey that is after 10. All right? So there's 90. All right? And so this subdomain is every jersey. Oh, let's change that to n again. Okay? Every jersey that is greater than 10. Okay? This is tough. This is one of the toughest problems probably in that section, right? So you got to be real careful with these. I'm not going to have a question this hard on the test, just so that you know. But I do want to give you a story problem that you would have to construct a piecewise function. All right? So that's that for this section. And long video at 14 minutes. Ooh. Okay, Atticus, what are you doing?